Hi and welcome back to Module 7, and today we're looking at properties of esters. So we've already looked at an ester and discussed about how an ester is made with that alcohol and a carboxylic acid. And in class we looked at the production of an ester and the conditions that are required to make an ester in the school laboratory. But what properties do esters have? So we already know they have that characteristic odour, but what are their chemical properties that they also have? So if we were to look at the structure of an ester, we'd notice that they do have a CO bond and also a C-double-O bond. The C-double-O coming from the carboxylic acid and the C bonded to oxygen coming from an ethanol. And this bonding here makes our esters polar substances. So esters contain no hydrogen atoms there, so there's no hydrogen bonding there, so their main intermolecular forces connecting them to others are the dipole-dipole forces. Now these aren't as strong as our hydrogen bonds that we would see in carboxylic acids and alcohols, so that would mean I would expect that they would be lower in terms of their boiling points and melting points. Compared to a carboxylic acid or an ethanol or an alcohol rather of a similar molecular size. So if we have a look here, we can see that that's compared. We've talked about they don't have the hydrogen bonding that the carboxylic acids have, but let's have a look here. If I've got a 2-carbon chain, our alkane boiling point about -89, an ester 32, alcohol 78, and our carboxylic acid significantly higher at 117. So you can see with our alkanes, there's just those dispersion forces there. The ester, the dipole-dipole, no hydrogen bonding. Our alcohol 78, and our carboxylic acid higher again. And you can see that with the same trend there for a 2-carbon chain, 3-carbon chain, and a 5-carbon chain. So here, if we're looking at the state of them, most esters have a really low boiling point. So at room temperature, about that 20 degrees, they are liquids. The larger esters might be solids, and that again might be due to their stronger intermolecular forces. Now with our solubility, we've already discussed solubility a little bit. They are insoluble in water, except for the really tiny ones. And that's because those small molecules will form hydrogen bonding with the water and therefore soluble. But as our carbon chain increases, they become more and more insoluble, which is a really great property when we're looking at separating them from the remaining acid and alcohol that may be still present in the reaction flask that we need to remove. Just a short video for today. We'll discuss it a little bit more with some questions in class tomorrow. See you then.